In this video we're going to look at masonry structures. So masonry structures are structures that are made out of individual bricks or stone units. So that the bricks or stones are sort of made and then you put them all together like Lego blocks. Although in this case here they don't lock together, they get stuck together by cement, or sometimes you actually rely on their weight to hold them together in case of big blocks, like say the big blocks of stone they used for the pyramids. Or smaller blocks can actually have dowels that hold them together, like keystone blocks. They're not suitable for floors because they crack with impact, or roofs or ceilings because they're only short, heavy sticks, and they're only really good for short spans. They can be load bearing if they're built on a wall, and they're often used as facades to timber or steel frames because they can provide quite an attractive appearance. So the types of masonry structures, or the types of materials, you can have stone. So you can see here they've just got a whole lot of big bits of stone and stacked them on top of each other. Doesn't look as though they're actually cemented together, but oftentimes they are. Oftentimes you'll put a cement core in the middle and just stick the stones to it, so it looks like they're being held together, but holding together under their own weight, but there's actually concrete in behind it holding it all together. Bricks, so normal just clay bricks made out of clay, put together, or block, which are concrete cast blocks. Now block is the most common thing used in New Zealand for construction. Over in countries like England, they are they like brick quite a bit. So it just comes down to what resources are available within an area. So the advantages of masonry: a masonry wall is a nice big thick block of clay or rock or cement or something like that, which means it has good thermal insulation, thermal mass. So it keeps the heat in. It can look good. Doesn't require painting or surface protection. Clay, rock, cement, they all weather really well. They don't rust or rot or anything like that. They actually survive a long time, as evidenced by the pyramids, which have been sitting there for what, 5,000 years. So weathering is really the only thing that affects it. Do not require painting or surface. Yep. Non-combustible, fire resistant, so they're less likely to catch fire than say timber. They're less affected by fire than say steel. They're heavy. They provide a stable structure. They're durable, as I mentioned, can last 500-year design life. High compressive strength, but low tensile strength. So the disadvantages is they're heavy. So the advantage is they're heavy, that they are stable, but they're expensive to transport, and you need good foundations because a masonry structure is going to be heavier than a steel structure or a timber structure, which means that the foundations are more likely to settle or fail. So you need to have good foundations. Brittle failure. So if they do break, they break very quickly, not like steel. Poor earthquake performance, so they're heavy and rigid, and when they start getting lateral loads, all that weight they've got gets transferred laterally, and unless it's got steel in it, it's actually going to break. Labour intensive, so each block has to be laid by hand, which takes time. Material intensive, use lots of unsustainable materials, clays and cement. Low tensile strength unless they're reinforced. So once again, when an earthquake hits, a masonry wall, if it's unreinforced, is a major problem. So most of the failures in earthquakes in New Zealand have been from unreinforced masonry structures. Once you put reinforcing in, it's got a certain amount of strength, but it will crack in an earthquake as well. So you get cracking, which has to be repaired. So the different types, so we looked at them, but the one most common in New Zealand is concrete block masonry. Made of unreinforced concrete, so it's cement and fine aggregate only. It's inexpensive, doesn't cost much. The voids, so it's got construction, it's got voids there, so normally what you do is you put reinforcing up through those voids, and then you cement them on top. So the void allows reinforcing to be spread up this way. And these type of blocks, so these blocks here, you can't really do it laterally. You can't really do the horizontal reinforcing. But these blocks are designed for horizontal reinforcing. So bond beam blocks, so as their name indicates, they can make beams. What you do is you smack that bit with a hammer, that bit with a hammer, and that bit with a hammer, and they crack. So the crack will appear along there. And so now you've got a void right along there, and you can actually put reinforcing steel horizontally and vertically as well. And then obviously you backfill the whole thing with concrete. So the voids can be, if you've got reinforcing in them, you have to backfill it with concrete. So when you get to the top, you just pour a whole lot of concrete in. The voids allow a continuous connection between all the blocks, so it fills. Or you fill them with concrete as you go. As you put a course up, you fill it with concrete, or 2 or 3 courses you fill it with concrete. So looking at the block wall itself, as I said, it has to have a really good foundation. Normally it's a strip foundation, sort of holding it together. Out of the strip foundation will be reinforcing bars sort of going vertically, and the voids in the block wall sort of align with that. When you get to the top, or when you finish, you fill it in with concrete to protect the steel and to bond the steel and the concrete to make it one structure. So you can see that yeah, damp proof courses, stuff like that. Now the other thing to notice here is the blocks here are staggered, so this this joint here does not line up with this joint there, and the reason for that is you don't want a continuous joint there because there's a plane of weakness. So what you normally do is you stagger the blocks so there is no plane of weakness. If it does fail, it'll fail like that, a 45-degree line normally, if this drops down. So masonry construction, the first thing you need to do is construct the strip foundation, as we sort of looked at in previous videos. Those strip foundations typically go down 600 mils, reinforced steel, stirrups or something like that, or longitudinal steel, or both. Then you fill it with concrete. Now it's important that you get the top of it at the right level, because that is the foundation of the concrete floor, and that it is the right shape, so it's also smooth. So you can see this guy sort of come out of the ground here. Normally when they're laying a course, so a line of bricks is called a course, they set up a string line between the 2 end blocks. They'll put the 2 end blocks in, then set up a string line, and they'll make sure that the tops of each block are actually on top of that string line. Now, I didn't mention it before, but the blocks are normally, so these blocks here, the standard blocks, are 390 wide and 190 high and 190 deep, which means that if you have a centimetre, 10 millimetres of concrete in between, it's going to be 400 centre to centre. So that's what it's designed for. 400 that way, 200 that way once you've put the mortar in between it. So it's worth considering when you're actually designing something like this as well. The reinforcing steel, so we saw that when they built the strip footing, they put the reinforcing steel up through the side of it. That's probably not as much reinforcing steel as you would have in a New Zealand house. This is obviously United States or some other place, maybe England. So normally you'd have it probably reinforcing steel sort of coming up every block. When you get to the top, you normally smooth it off, so you pour the concrete into the voids, smooth it all off. You can see here the reinforcing steel keeps on going all the way up the top there, because what they're doing now is they're going to put a wooden topping to the whole thing, and then they'll put the timber roof on top of that wooden thing. So the finish here, the reinforcing steel goes out there, they put timber on top, drill a hole, put that on top, so the reinforcing holds it onto the block. They'll probably drill some masonry holes into it as well, and then they'll use that timber to nail the timber roof onto it. So that concludes what we're looking at for masonry. I suggest you go and have a look at this video here on YouTube. Just type in that code and you'll get it. It gives you a really good overview of construction of a masonry wall.